Next, we are going to see delivery, forwarding, and routing. First, what is delivery? Delivery refers to the way a packet is handled by the underlying networks under the control of the network layer. So, what is delivery? Delivery is a way in which the packet is handled by the underlying networks under the control of network layer. Forwarding refers to the way a packet is delivered to the next station. What is forwarding? Forwarding is nothing but the way in which a packet is delivered to the next station. Now, what is routing? Routing refers to the way the routing tables are created to help in forwarding. What is routing? Routing refers to the way the routing tables are created to help in forwarding. So, routing protocol. Routing protocols are used to continuously update the routing table. So, what is routing protocol? The use of routing protocol. So, routing protocols are used to continuously update the routing tables that are consulted for routing and forwarding. First, delivery. The network layer supervises the handling of packets by the underlying physical networks. Okay, network layer is a layer which is, supervises the handling of packets by the underlying physical networks. This handling is defined as the delivery of packet. Okay. So the delivery of a packet to its final destination is accomplished by two different methods. So there are two different methods to deliver a packet to the final destination. The two methods are, one is a direct method and another one is an indirect method. So first, direct delivery. In a direct delivery, the final destination of the packet is a host connected to the same physical network. Okay. So what is direct delivery? So in direct delivery, the final destination of the packet is a host connected to the same physical network. So direct delivery occurs when a source and destination of the packet are located in the same physical network, or when the delivery is between the last router and the destination host. In two cases, direct delivery will occur. One is if both the source and destination are in the same physical network, or when the delivery is between the last router and the destination host. So indirect delivery. So indirect delivery means if the destination host is not the same network as the deliverer, the packet is delivered indirectly. Okay. If the destination host is not present in the same network, then we have to go for indirect delivery. So in indirect delivery, the packet goes router to router until it reaches the final destination. Okay. So what is indirect delivery? In indirect delivery, a packet goes from router to router until it reaches the one connected to the same physical network as its final destination. So this is direct delivery. Direct delivery means both the source and the destination are connected to the same physical network. So here source is in one physical network and the destination is in another physical network. So here we are going for indirect delivery. So it will be transferred from router to router until it reaches the destination. This is direct delivery and indirect delivery. So next one, forwarding. Forwarding means to place a packet in its route to its destination. So what is forwarding? Placing the packet in the route to its destination is called forwarding. So forwarding requires a router to have a routing table. If you want to forward, then we need a routing table. When a host has a packet to send, or when a router has received a packet to be forwarded, it will look this routing table to find the route to the final destination. Whenever a host is having some packet to send, or whenever a router is getting a packet to be forwarded, it will look the routing table and it will find the route for the final destination. So forwarding techniques. So first one is next to hop method. One technique to reduce the contents of a routing table is called next to hop method. So in this technique, the routing table holds only the address of the next hop instead of the information about the complete route. So in the next to hop method, you will be using only the address of the next hop or the next station, and you will not be having the details about the entire route. So the entries of a routing table must be consistent with one another. Okay, here in this next to hop method, the entries will be consistent with one another. So first one, this is a routing table based on route, and this is a routing table based on hop. So you are having a host A which is connected to the network 1, and you are having a host B which is connected to network 2, and this is a network 3. So a router is connecting the host A with the network 3, and host B is connected through a router R2. So if it is if the routing table is based on a route, then here the destination is host B. Then how it has to go? It has to go through R1, R2, and it has to reach the host B. Okay, so this is a routing table. For in the A, it will the routing table. Then this routing table for R1 is R2 host B, and in B it is host B. So now if you are using the routing table as a next hop, then what we will be having for host A routing table, just we will be having the information about this R1 only. So host B, destination is host B, and we have to go for through R1. Next here in R1, what will be having means destination is host B, we have to go by R2. So the final in this host B will be having host B. So this is the next hop method. In this next hop method, we will be having the information regarding the next hop only, and we will not be having the information about the entire route. So next one is host specific method. The second technique is to reduce a routing table, and to simplify the searching process is called a network specific method. So here, instead of having an entry for every destination host connected to the same physical network, only one entry that defines the address of the destination network itself. So here, instead of having an entry for every destination host connected to the same physical network, you'll be having only one entry that defines the address of the destination network itself. We treat all the hosts connected to the same network as one entity. So if you're having some 10 hosts connected to a network, then you will be considering all the 10 hosts as one entity. So if 100 hosts are attached to the same network, only one entry exists in the routing table instead of 1000. So we are going to see the diagram, it will be clear. So here you are having a source S, and it is connected to the network N1, and you're having one router R1, and some 4 devices A, B, C, D are connected to network N2. So the routing table of this host specific method is, if the routing table is based on host specific method, then how means for A it has to pass through R1, for B it has to pass through R1, C it has to pass through R1. So now in this network specific method, what you are doing means, for all these things what you are doing is you are putting a destination as N2, because this A, B, C, D, all these things are connected to the network N2. So you are taking this A, B, C, D into one entity called N2. So in the routing table, you are adding this information N2. Okay. So next to hop is R1, and the entity network, we are using the network N2. Okay, this is the second method. Next one is a default method. So in the default method, so we will came to this one. So here in default method, how you are making this routing table means you are having a host A which is connected to N1 and some devices is connected to N2 through router R1, and so all other networks is connected to the router R2. So in default method, if the destination is N2, you have to go through the router R1. If any other networks means you have to go through the default router R2. So this is something called default routing. Okay, this is called default router. So this is a simple routing method.